Welcome to solving trig equations, everyone. This is Nicholas. I seem to can't get this video right, JMV. It's like the fourth time I've tried to do this. So it's one example, and we'll see if we can get through this without doing any mess ups. Okay, so we have tangent of 3x equals 1. We're going to solve that equation on the interval from 0 to 2 pi. So here's what we know. We know that tangent of pi over 4 equals 1, okay, on the interval. That's what we know from our unit circle, okay, pi over 4. It also equals that at 5 pi over 4 down here, but we're not going to use that right now. We'll get to that answer, but we also know that tangent repeats every pi, okay? So we know that pi over 4 is equal to 1, but we need to know that if x equals pi over 4, that equals 1. But we don't have x. We have 3x, okay? And we want that to equal pi over 4. But we also want this idea of a general solution that times or plus n times pi. Plus n times pi, because we got to account for the number of periods. How many times we're going to go around? How many periods do we want to get to? General solution, even though we're only working with 0 to 2 pi here. So if I multiply everything by 1/3, I get x equals pi over 12 plus n times pi over 3. There's my general solution, okay? And now they want solutions from 0 to 2 pi. Pi over 12 is really small. It's 1/12 of of pi. So we need to think about how many times can we go around this unit circle, how many n's that we use. So let's let n equal, and I'm going to show you the first 3, and then after that I'll show you how to get the rest. N equals 0, n equal 1, n equal 2, okay? Now, when n equals 0, okay, we're just going to go ahead, we're going to have x equals pi over 12 plus 0 times pi. I like different colors here. 0 times pi over 3. And guess what? There's your first solution, okay? So pi over 12. So think about this. If you took 3 times pi over 12, right, you'd get pi over 4. Tangent of pi over 4 equals 1, so that works out. Now, when n equals 1, you're going to have pi over 12 plus 1 times pi over 3. Whoops. Okay? And so you have pi over 12 plus 1 pi over 12, or 1 pi over 3. And so if you multiply this by 4, it's 4 pi's over 12. So this becomes 5 pi's over 12, right? Common denominator times 4 times 4, okay? And you get your solution there. Let's do one more of the solutions here when n equals 2. So you have pi over 12 plus 2 pi over 3. Okay, so this becomes pi over 12 plus, if you multiply this by 4 and 4 common denominator, that's 8 pi's over 12. That's 9 pi's over 12, or 3 pi over 4. Okay, so now you're thinking, oh, I've done that, I'm done. I've got pi over 12, 5 pi over 12, 3 pi over 4. I'm not done yet. That's only 3 pi over 4. That's 3/4 of 1 pi. Remember, I have to go to 2 pi. So you actually have to go n equals 3, 4, and 5 to get the remaining 3. When you get n equals 3, you get 13 pi over 12. When n is 4, you get 17 pi's over 12. We're getting there, right? And then when n equals 5, you get 7 pi over 4. If you did 6, let me show you why we don't use 6, okay? N equals 6 here, because you would take pi over 12 plus 6 times pi over 3. Now, 6 times pi over 3, that's 2 pi. That's already too much past this, so that won't work. Okay, so our solutions are pi over 12. Okay, 5 pi over 12. 3 pi over 4. I got a 13 pi over 12. 17 pi over 12, and 7 pi over 4. those are all the solutions from 0 to 2 pi of this multiple angle. So if you have any questions or comments on that or how to do it, go ahead and type them below, and we'll see you next time.